Hi everyone. In this video, we will study about the feed mechanism in a shaper. So, in case of a shaper machine, the feed is provided intermittently and at the end of the return stroke, as similar to a shaper machine. And both the downfeed and crossfeed of a planer is given by the tool. And the crossfeed is given while machining horizontal surface and downfeed is applied while machining a vertical or angular surface. So the power feeds may be applied by two methods. First one is friction disc and the second one is by electrical drive. So in this video, we will study about the feed mechanism by friction disc. So the major difference between the feed mechanism of a shaper and that of a planer is that in a shaper, when the bull gear rotates through one complete revolution, the ram holding the tool completes one forward cutting stroke and one return stroke. And by the ratchet and pole mechanism, half of the revolution of the bull gear is used to impart feed movement and during other half no feed movement is given. But in case of a planing machine, the length of stroke of the table is quite long and the bull gear will make a large number of revolutions in the forward cutting stroke and the same number of revolutions in the return stroke. So in case of a shaper, when the bull gear completes one revolution, both the cutting stroke as well as the return stroke is completed. But in case of a planer, when the bull gear rotates more than 2 or 3 times, only one stroke is completed and the same number of revolutions has to be completed by the bull gear for the return stroke. So this is the main difference between a shaper machine and a planer. So by friction feed disc, only a part of the revolution of the bull gear is used to operate the feed gearing at the end of return stroke. And during the rest of the period, the feed mechanism remains inoperative. So, the feed motion. So, this is the feed mechanism by a friction disc. So, here you can see a shaft, then a flange, and both sides we have washers. Then this is the feed disc, then a projecting pin, then connecting rod and a block. So this is the figure. So this is the sectional view of the feed disc, and the feed disc consists of two parts having a cylindrical opening which encloses the flange. So this is the feed disc and it is of two parts having a cylindrical opening, and in that cylindrical opening we have a flange, and this flange is connected to the shaft. This flange is connected to the shaft. And this shaft is the intermediate shaft. In open and crossbell drive we studied this. So this shaft is the intermediate shaft and which is connected by the feed disc. Okay. Now leather washers are provided on both sides of the flange. So leather washers are placed between the flange and the disc opening, and the bolts are then tightened. So a flexible connection is now made between the shaft and the feed disc with the help of this leather washers. So this figure shows the end view of the feed disc showing the driving mechanism of the feed screw. So here we can see the feed disc, and a T-slot is cut radially on the face of this feed disc, within which a block is connected. So by rotating the knurled knob, the position of this block can be changed. So here you can see a projecting pin connected to the feed disc. A projecting pin is connected to the feed disc, extending beyond the body. So when the shaft rotates, so here you can see this is the shaft, and we have a T-slot on which a block is connected. So when the shaft is rotating during forward cutting stroke, the motion is transmitted to the feed disc by the flange. So when the shaft is rotating, the disc also rotates, and the motion of this feed disc is limited by, so when the shaft is rotating, the feed disc also rotates, and the motion of the feed disc is limited between these two pins. So the motion of the feed disc is limited by the projecting pin hitting against a fixed pin which is fitted upon the machine frame. So when the disc rotates through a part of the revolution, the flange connected to the shaft continues to rotate within the disc, slipping over the leather washers throughout the cutting stroke. So after hitting this pin, what will happen? The feed disc will not rotate, but the shaft as well as the flange will rotate. So the flange will slip through this feed disc with the help of this washers. So flange will rotate, but the movement or the rotation of the feed disc is limited between these pins. So during one rotation, the projecting pin starts from here and it hits on this fixed pin. So thereafter the feed disc will not rotate, but the flange as well as the shaft rotates. So now when the table is reversed, the shaft starts rotating in opposite direction, and the disc rotates through the same part of the revolution in the opposite direction due to the pin hitting against a second fixed pin mounted on the machine frame. So when shaft during the return stroke, what will happen? The shaft rotates in opposite direction. So when the shaft rotates in opposite direction, the flange rotates, so as the feed disc also rotates, and the movement of the feed disc is restricted from this fixed point or fixed pin to this fixed pin. So now the feed disc will rotate from this point to the other fixed pin. So when the planar table reciprocates, the feed disc rotates through a part of the revolution in one direction at the beginning of cutting stroke, and again it rotates through the same part of the revolution in opposite direction at the beginning of return stroke. So during the other times, the feed disc remains constant. That is, only at the beginning of cutting stroke, the feed disc rotates from this point to this point, and the remaining portion, that is, during the completion of this cutting stroke, the feed disc remains in this position. And when the return stroke occurs, at the beginning of return stroke, what will happen? The feed disc moves from this point to this point, and during the completion of the return stroke, the feed disc remains constant. So the rotary movement of the disc is transmitted to the rack. Is transmitted to the rack through a connecting rod. So the rotary movement of the disc. So when the disc moves from this point to this point, what will happen? The rack also, the motion is transferred to the rack with the help of this connecting rod. So this rotary movement of the disc is transmitted to the rack through the connecting rod, and a pinion is mounted, on this shaft. So this is the pinion shaft. So a pinion is mounted on this shaft which meshes with the rack. So this pinion meshes with this rack and it receives a rotary movement. So since this pinion is meshing with this rack, the pinion receives a rotary movement. And now we have two gears mounted on this particular shaft. So this is gear 1. So this is gear 1 and this is gear 2. So we have two gears mounted on this shaft, and gear 1 is keyed to this shaft and gear 2 is free. That is, whenever this shaft rotates, gear 1 also rotates, but gear 2 will not rotate. It is free. And a double pole. So here we can see a double pole. So a double pole is pinned on the face of gear 2. So a double pole is pinned on the face of gear 2, and any one end of the pole may be pushed into the tooth space of gear 1. So here we have a double pole and any one end of the pole may be pushed into the tooth space of the gear 1. So when the left hand end of the pole is pushed within the gear 1. So when the left hand end of the pole is pushed within the gear 1, the upward movement of the rack. So during the rotary motion of the feed disc, the rack will move upward. So during the upward movement of the rack, what will happen? When this double pole is in mesh with the gear 1, during the upward movement of the rack will cause gear 1 to rotate in clockwise direction. So the gear 1 rotates in clockwise direction, and this motion is communicated to gear 2 with the help of this double pole. So when the gear 1 is rotating in clockwise direction, gear 2 also rotates in clockwise direction. And when the rack is moving downward, so during the rotary motion of this feed disc, the rack will move downward. So when the rack is moving downward, the gear 1 will rotate in anti-clockwise direction and no motion is transmitted to gear 2, since the double pole or the pole will slip over the teeth of gear 1. So during anti-clockwise direction, the pole is not engaged or it is not meshed to the gear 1 teeth of the gear 1. So during the other half of the rotation, the rack moves downward so as the gear 1 rotates in anti-clockwise direction and the double pole or the pole slips over this teeth and no motion is transmitted to gear 2. So the gear 2 will rotate through a part of the revolution in one direction only during a complete double stroke of the table, and it may be so arranged that the gear 2 will operate during the beginning of cutting stroke only. So the gear 2 is made to mesh with two sliding gears. So the gear 2 is in mesh with two sliding gears mounted upon two feed shaft. So here you have a cross feed shaft, and this is the cross feed shaft gear, this is the down feed shaft, and this is the down feed gear. So the gear 2 is in mesh with down feed gear as well as the cross feed gear. So whenever this gear 2 is rotating, that motion is transmitted to the gear on the down feed shaft as well as the gear on the cross feed shaft. So both these shafts will be engaged or will rotate, and the feed motion is imparted to the tool head by rotating these feeds separately or together. And the direction of feed movement may be reversed by changing the position of double pole. And the amount of feed may be varied by shifting the position of this block with respect to the center. So this is all about the feed mechanism by friction disc. Thank you.